Hi, everybody. This is Mr. Folly, and let me get rid of this, and welcome to our last podcast of heat. 7.4. All right, so we're going to look at heat and reactions. So a little bit of what we have to do is little hump diagrams again, which I think we talked about a bit, but that's it. So what you have to do for these energy profile things is you get a graph that looks like this, or it'll just have one hump, okay? The reactants are found on the left. Here are my reactants. They may include catalysts. We're not even going to worry about that right now. It's going to be found on the left. Products are the ending materials. These are the products. We're not going to have catalysts in this unit. The transition state is the highest spot. This is my transition state, right? Highest peaks. This is my transition state. And this one, here's my reactant I'm starting with. This is my transition state. Okay? They'd have a bad Lewis dot structure, and they indicate the number of steps in a reaction, which we don't. You're only going to have one for this. The activation energy is the energy from the reactants up to the products. Okay? That's the highest barrier. From the reactants up to the highest barrier. Okay? Delta H. This is what's really on your test. Delta H is the difference from my reactants to my products. That's it. From my reactants to my products, so it's the number right here. So if I put numbers on it, I would just subtract it. So if this is 100 and this was 10, delta H equals negative 90 because it went down. And if this is 100 and this is 135, delta H is positive 35 because it went up 35. And you should know if it ends lower, exothermic, ends higher, endothermic. Dun, 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 dun. Oops. And that's the meanest part about it, okay? Exothermic, putting the heat term in, okay? So we did this last time, and it was a struggle. Delta H puts kilojoules on the right. Positive delta H puts kilojoules on the left. Graphically, it goes down here. So, right? So this is exothermic. And this has a negative delta H, all because it went down. This one right here is going to be endothermic. Why? It went up in energy from my reactants up. It would have a positive delta H. And by the way, kilojoules would be on the left. Okay? And this one, kilojoules, will be on the right. I can spell right. Kilojoules is on the right. Okay, so again, what do we need to know about endothermic and exothermic? Let's make it a little clearer on here. I'll do exo and endo will be the same. It'll be the opposite. Exo. What's it look like? It goes down. Kilojoules on the right. Heat on the right. More bonds, bond energy in forming products. Okay, endothermic would be the opposite. Graph up ends up higher, right? Kilojoules on the left, heat on the left, and then more energy in breaking reactants. There you go. All right, so now the part that's the beastie. Chemical reactions occurs when bonds are broken or formed. Lewis dot structures show the bonds. We've done this before. See this? So I have a C to H covalent, C to H covalent. This has 4 C to H covalent bonds. Breaking absorbs energy, releasing energy, forms bonds, barf. Okay? So now what we're going to do is we're going to actually calculate this. So this means breaking is positive, forming is negative, and I'm just going to combine them. So do you see how there's a big divider right here? This is my break, which means it'll be positive. This is my form, which means it'll be negative. So let's count them out. 1, 2, 3, 4, 5, 6, 7, 8. 8 C to H's. And I have 1, 2, plus 2 C to C's. And then I have 1, 2, 3, 4, 5, plus 5 O double O's. Plus 1, 2, 3, 4, 5, 6. 6 C double O's plus, I gotta have negative in there because they're forming. Then I have 1, 2, 3, 4, 5, 6, 7, 8. 8 negative O to H. And that's going to be, that's going to be the delta H, the reaction. Okay, so let's put a little math into this. C to H, 413. Hi, Kelly. Hi. Plus 2 carbon is 348. Plus 5 O. Now this is the O and O2, so we're going to use that. 495 plus 6 times negative carbon to oxygen is a double. It's double. Carbon to oxygen double, 799 plus 8 times negative O to H. I'm so slow finding this day. Negative 463. I put it in my calculator and get my answer. All right, so put that in your calculator and get your answer. Gee, I wonder if that's going to be a question on the pod quiz. No, I don't. I know it is. You have to do it on your own. Okay, and then it says draw the PE diagram doing this. So when I do this, this actually comes out to be negative something. Dun, dun, dun. So my PE diagram would be, you still have to find that number. Is there action between CHCl2 plus Br2 yields CHBr2 endothermic or exothermic? Calculate the energy involved in this reaction. So same thing. I strangely have some weird little dots circled in here, but I've got, so let's figure them out. I got C to Cl, so I have 2 times C to Cl plus 2 times C to H plus Br to Br plus, oh man, that's hard to see, CH2Br, so boom, boom. Now I'm forming them, so 2 times negative C to H plus 2 times negative C to Br. Hey, hey. It's your favorite. Plus negative Cl to Cl. Okay, so now I just got to put those numbers in. Bum, 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 bum. So 2 C to Cl. C to Cl is 328. Oh, man, you're busy. So 2 times, yeah, you're in the video. Want to say hi? Hey, hey. 328 plus 2 times C to H, 2 times 413, plus Br to Br. There it is. I wish I could see that better. I'm going to call that 183. Whatever it is for real, that's the number you should use. Okay. Plus 2 times negative C to H, negative 413. Plus 2 times negative C to Br. C to Br is negative 276. You probably can read yours better than I can read mine. Plus Cl, negative Cl to Cl, negative 242. I put those in my calculator. I get an answer that will be a question on the podcast. Okay. And then, I guess I'll put this one. I'll actually do this one because then I'll know whether it's endothermic or exothermic. So here we go. 2 times 328, enter, plus quantity 2 times 413, plus quantity 183. I guess I didn't need a quantity there. Plus, I had equals, plus quantity 2 times negative 413, close quantity, plus quantity 2 times negative 276, close quantity, plus negative 242, enter. So I get positive 45. So because it's positive 45, my graph is endothermic, and it goes like this. Ba-dum, bump, bump, ba-dum, bump, bump. That's it. Toodles.